to the lungs. Now, because the transport of carbon dioxide and oxygen are tightly coupled, we'll begin this lesson by explaining how oxygen is taken up by the circulatory system. Oxygen uptake begins as it diffuses across the alveolar epithelium into the pulmonary capillaries. Approximately 99% of the oxygen diffuses into the red blood cells, 98% of which binds to hemoglobin to form oxyhemoglobin, while the other 1% dissolves in the red blood cell cytosol. The remaining 1% of oxygen dissolves directly into the plasma. Of the oxygen that binds hemoglobin, 90% displaces hydrogen ions, while the other 10% displaces carbon dioxide. Once oxygen is taken up by the red blood cells are transported throughout the circulatory system. As the oxygen-rich red blood cells reach the capillary beds within tissues, the oxygen is released from the red blood cells in exchange for carbon dioxide. Of the carbon dioxide that is produced and released from tissues, about 5% dissolves directly in the plasma, while the other 95% diffuses into the red blood cells. Now, inside the red blood cell, 85% of the carbon dioxide combines with water and is rapidly converted into carbonic acid by the enzyme carbonic anhydrase 1, or CA1 for short. Following this reaction, carbonic acid is rapidly and spontaneously converted into bicarbonate and hydrogen ions. To keep the reaction moving toward the formation of bicarbonate and hydrogen ions, the bicarbonate ions are immediately transported out of the red blood cell in exchange for chloride ions via the bicarbonate-chloride exchanger. This transporter is referred to as the anion exchanger 1, or AE1 for short. Sometimes it's referred to as band 3. Also, it's important to note that the transport of chloride ions into the cell helps maintain the electroneutrality of red blood cells. This is often referred to as the chloride shift. After being transported out of the red blood cells, the bicarbonate ions readily dissolve in the plasma. So, about 85% of the total carbon dioxide transported throughout the circulatory system is transported as bicarbonate ions dissolved in the plasma. Now, the hydrogen ions remain in the red blood cell because they're relatively impermeable to the cell membrane. So, they lower the intracellular pH, which causes oxygen to disassociate from hemoglobin. Next, the hemoglobin buffers the intracellular fluid by binding the hydrogen ions. Now, the other 10% of the carbon dioxide that diffuses into the red blood cells displaces the oxygen on the oxyhemoglobin to form carboaminohemoglobin. Next, these oxygen-poor red blood cells travel back to the lungs, where the low carbon dioxide tension and high oxygen tension cause the reaction to proceed in the reverse direction. As a result, the increase in intracellular bicarbonate ions increases the intracellular pH. Together, the increased intracellular pH and the increased oxygen tension promote the release of hydrogen ions and carbon dioxide from hemoglobin in exchange for oxygen molecules. Now, the free hydrogen and bicarbonate ions spontaneously and rapidly form carbonic acid, which is then rapidly converted back into carbon dioxide and water. Together, the converted carbon dioxide and carbon dioxide released from carboaminohemoglobin diffuse out of the red blood cell into the alveolar sac.